So today we are going to learn selection sort algorithm analysis. So what is the algorithm? Let's see first. Algorithm, and the first things what we are doing selection sort, and so we need to take some array. So what we have in the list, we can see the array of items, and definitely because we are doing sorting, so there is a fixed size or some size should be there. So we are supposing the list size is n. So what we are doing sorting based on the selection, right? So this is the algorithm. So based on the algorithm, I'm going to discuss the time complexity of this. So in this algorithm, first, what we are having one for loop in which what we are doing, we are starting from the first element to n minus 1, the second last element, not up to n minus 1. And what we are doing in the next line, in this line, what we are doing, we are initializing the first element as a minimum element, we are supposing, because we need to do comparison, so we need to take it like this. So initially first element we are taking as minimum. Now in the second for loop, what we are doing, we are starting it from I plus 1 to n. We are not starting from the 1. From where we are starting, we are starting from I plus 1. It means we are starting from the second element, because what is the I value initially? We have taken 1. So 1 plus 1, 2. So we are starting from second, and where we are going? We are going up to n. Here, where we are going up to n minus 1. So this is the difference between these two for loops. And after that, what we are doing? We are cross-checking if list of j, whatever element we are cross-checking at j, if it is less than the minimum. Because minimum is was what we have supposed? We have supposed the I. So if the jth element is the minimum than this, then what we are going to do, because it initially we have supposed that I is minimum, and if we are finding that j is minimum, then what we are doing, we are putting the j value into the minimum, so that we can place the correct value, right? So we are able to see there are two for loops. So as we know, for loop, it will start from 1 and it will go to n minus 1. So we can say it will go up to n. We can say it will go up to n, right? So this here we can say it will go up to n time, n, right? Now again another for loop, it is also starting from I plus 1 to n. So it will also go up to n time, right? It will also go up to n time. So there are, so we are able to say from this only that if two for loops are there and one is inside, because we are doing comparison every time, because we are comparing first element with the second element, as we are able to see the I is starting from 1, so first element, and j is starting from I plus 2, so second element. So we are comparing first and second element, so it will go up to n time maximum. So both are working. So we can say n square, we can say n square, and every time we are comparing, if anyone is minimum, then we are putting into minimum. In the similar way, we are going ahead. And what if index? So end of if, end of for. So here if is ending, we are comparing, then if we are ending if, and we are ending for, right? And after that, what we are doing, if index minimum is not equal to I, then if minimum is not equal to I, then what we are doing, we are swapping. We are swapping minimum with the list I. We are swapping minimum with the list I. So after that, we are swapping also. So total n number of elements are there. So we can say n minus 1 swapping. From here we are able to see n minus 1 swapping, because n elements are there. So maximum n minus 1 swapping can be possible. So we are able to see here clearly that comparison will be, because total n elements are there. So n and n minus 1 comparison will be there, right? Because every time we are comparing first element with the second element with the third element. So n minus 1 plus, if it is not less than this, then we need to do swapping. So total n minus 1 possible, because total n elements are there. So we are able to see n into n minus 1, so it will be n square. From here, these two loops also we are able to see, because n square is the time complexity. Maximum it can be, or minimum it can be n square. So in this way, we are able to see the selection sort complexity will be this. So now we are moving towards the application of the selection sort. What are they? We are able to see from here. Selections sorting, the real time. What it can do? It can sort real time data stream or we can say the data is, when data is continuously flowing, then you need to keep the data in sorted order whenever new element is coming over there. So in this way, this algorithm works in real time. And what is the next application? In embedded system, we can say with when limited resources and IoT's devices are there, then we need to sort incoming data in real time. So it works in efficient way, and it also consume less memory as compared to other. And what is the next one? We are able to see when whenever we are doing shopping, as it is a general, we used to do shopping a lot. So on Amazon and anything, if we are sorting something based on our choice, so how we sort? I am taking one criteria, so based on the price, so we are sorting from low to high or high to low. So these are the three real-time application of this algorithm. So hope you like it. If you like it, subscribe it, comment below. And if you want to discuss some specific topic, then let me know in the comment. Thanks.